Now we are going to take up one more problem on the projections of lines. So the problem reads like this. Draw the projections of a line capital AB 100 mm long, inclined at 45 degrees to VP and 30 degrees to HP. One end of the line is 20 mm above HP and is in VP. Determine its apparent length and inclination. So here he says draw the projections of a line capital AB 100 mm long. So he has given the true length, inclined at 45 degrees to VP and 30 degrees to HP. So he has given the true inclination with respect to VP and also the true inclination with respect to HP. One end of the line is 20 mm above HP and in VP. One end of the line is 20 mm above HP and in VP. So if you look from the front view, we can see the distance above HP, the distance is 20 mm. So we can see the distance in VP. So you're going to mark this point as A dash and then you mark this point as capital A. And in VP, so when you look from the top view, that point is on vertical plane. So when it is projected, so that will going to pass on the horizontal plane, which will be on XY line. And as he says that it is 100 mm long, is inclined at 45 degrees to VP. So from this point A, you draw a line at an angle of 45 degrees to VP of length 100 mm. So the inclination with respect to VP is seen in HP. So when you look from the top view, we can see that inclination here. So that inclination, when it is projected onto the top view, it will be on HP. So you're going to get that AB2 is the line which is inclined at 45 degrees to VP and the length of the line is 100 mm. Once you get this B2, so now we got the locus of B in the top view. And then 30 degrees to HP. The inclination with respect to HP is seen in VP. So A dash is there on the vertical plane. So with A as center, A dash as center, and then you measure an angle of 30 degrees with respect to with respect to HP. Inclination with respect to HP is seen in VP. So you draw a line inclined at 30 degrees to HP of a length of 100. Once you get this point B1 dash, and here in this case B1 dash and B1, capital B1, both will going to be on the same line. That is because A is in VP, so naturally it will be on HP. So it is 20 mm above HP, so it will be on the vertical plane. So once you get this B1 and B1 dash, so you're going to get the locus of B in the front view also. Now we need to find out the apparent length and inclination. So we need to find out the front view and top view. So to find out the top view and front view, first we're going to consider the top view now. So to do that, we know that A is above HP by 20 mm. So B1, B2 should also be above HP by 20 mm. So that is the line which is true length, which is parallel to HP. Since it is parallel to HP, when it is projected, you are going to get the true length in HP. So when this is, so now we want the line to be taken from the, I want to find out the top view. So with capital A as center, you're taking the radius of A, capital AB1. You rotate it such that, so when you look from the, you rotate it such that B1 will going to cut the locus of B in the top view. How it will going to consider? So when you look from the top view, this A dash, B1 dash, which is the front view, when it is projected, A is on XY line, so B1 should also be on XY line. So AB1 is parallel to XY. Since the top view line is parallel to XY, so we are getting the true length in front view. So we have A dash, B1 dash in the front view. As capital A with A as center, AB1 as the radius, when you rotate, the image is also getting rotated such that capital B will going to cut the locus of B in the top view. So we are going to get this point. So now, once you look from the top view, that B is projected, capital B is projected onto the locus of B. So you're going to get small ab, then join A to B with a dark line. Now, once you get the apparent length on the top view and also the apparent inclination with respect to VP is beta. Now we need to find out the front view. To find out the front view, we have to take the top view true length. So we know that this is capital AB2 is the line which is the capital true length, because A is above HP by 20 mm, B2 is also above HP by 20 mm, so the line is parallel to HP. So since the line is parallel to HP, so in HP we are getting the true length. So that is small AB2. Now what we want to do? So we want to find out the front view. So to this line we need to write the front view. When it is projected B2, the B2 dash is also above HP by 20 mm. So A dash B2 dash is the line which is parallel to XY line in the front view. So obviously the top view will be in true length. So you have got the top view in true length. Because due to the presence of the locus of B in the front view, so A dash is center, B2 dash is the radius, you rotate it such that it will going to cut the locus of B in the front view. So you are going to get this as B dash. In other words, join A dash B dash with a dark line. So in other words, what we are doing is we are taking the capital AB2 and you are rotating such that the B2 will going to cut the locus of B in the front view. So when it is projected, it will going to fall on the vertical plane. So you're going to get this as B dash and then join A dash B dash with a dark line. So the inclination made by the front view with respect to HP is called alpha. So how to analyze this when you are going for the individual? Now we are considering, so I want to write the top view now. To write the top view, we need to consider the front view true length. So we know that A dash B1 dash is the line which is in the true length because it is given. So capital AB1 is the line which is in true length. So if this line has to be in the true length, so in the top view that line has to be parallel to XY. So A is in HP. So B1 should also be on VP. So both AB1 is the line which is parallel to XY. Since AB1 is parallel to XY, so its corresponding front view will going to be in the true length. So with A center, taking the radius of AB1, when you are rotating and it make it parallel, when you are rotating such that this B will going to, so what happens since you are rotating in space, the line is also getting rotated. That is the image when you look from the top view. That rotational image will going to be from AB1, so it will going to cut the locus of B in the top view. So you will going to get this point here. So this is the position of this point. So this will going to be capital AB, which is in space. So here we are going to get the top view line. So we are doing the same thing in the orthographic view with you know A dash B1 dash is in the true length. So I want to take the top view of this line. Since it is in true length in the front view, so obviously that line should be parallel to XY in the top view. So A is on XY line, so B1 should also be on XY line. So from B1 dash you project it so that it will go to touches the XY line and you mark this point as B1. With A as center, taking the radius of AB1, you draw an arc so that it will going to cut the locus of B in the top view. So you mark this point as B and join A to B with a dark line. So you're going to measure that angle as beta, which is 54.74. And since I want to find out the apparent length, small AB will be equal to 86.60. Similarly, now we need to find out the front view and its true length. So to find out the front view and its true length, so we need to take the top view true length. So which is the top view true length? That is AB2. So AB2, it is true length in HP. Why? Because capital AB2 is parallel to HP. So A is above HP by 20 mm and capital B2 is also be above HP by 20 mm. So the line is parallel. Since this line is parallel to HP, so you are getting the true length in HP. So the corresponding front view, what will going to happen? So when you are looking from the front view, A dash is on here above HP by 20 mm. So B2 should also be above HP by 20 mm. So therefore, A dash B2 dash is parallel to XY line. So its corresponding line AB2 will be in true length. So with A center, taking the radius of AB2, you rotate it such that since you are looking from the front view, so obviously that image from B2 dash is also be getting rotated such that it will going to touches the locus of B in the front view. So you're going to mark this point as B dash. So that is how we are showing the rotation in space. So you're going to get this point here, capital B. Then join capital A to capital B here. So obviously you join between A dash to B dash, which is the dark line. So this will going to be the angle alpha. So how to show this in orthographic view? So here we are considering the top view true length, which is AB2, which is of 100 mm length, having angle 45 degree. So we know that A dash is above HP by 20 mm. So obviously its corresponding front view should be in parallel to xy. So what is the corresponding top front view? A dash B2 dash. A dash is above HP by 20 mm. So B2 dash should also be above HP by 20 mm. Therefore, from B2 you draw a vertical projector such that it will going to cuts the locus of A here, and you mark this point as B2 dash. As the locus of B in the front view is here with A dash as center taking the radius of A dash B2 dash, you rotate it such that it will going to cut the locus of B in the front view. So you mark this point as B dash and join A dash B dash with a dark line. So when you project both B dash and B, both will going to lie on the same line. So this is how you will be able to find the solution. So you measure the angle alpha. The alpha is 54.74. Alpha is 45 degree, and A dash B dash will going to be 70.71 when you are doing it in computer. When you are doing it in manual, it will be 71, and AB will be equal to 87 mm. Alpha is 45 and beta will be equal to 55 degrees. So this is how you will be able to solve this problem. Now we want to do it manually now. First we are going to draw the XY line and identify the planes as VP and HP, mark XY. So from XY line you measure 20 mm and draw a horizontal line. Consider any point. From here you draw a perpendicular to XY line and you mark this point as A and you mark this point as A dash. Then by using the protractor with A dash as center, taking the measuring an angle of 30 degree with respect to the horizontal, you draw this inclined line. Similarly, with A as center, measuring an angle of 45 degree to below XY line, you draw an inclined line. Then by using the compass, you measure the distance of 100 mm with A dash as center, cut an arc on this 30 degree line, so that you will going to get this point as B1 dash. Similarly, with A as center, taking the same radius of 100, cut an arc on that 45 degree line, you mark this point as B2 and you mark this point as B1 dash. Then draw a dash dot line here, and similarly you draw a dash dot line here, and then join between A dash and B1 dash and join between A and B2. Now once you do that, so here mark this as locus of B and you mark this as locus of B, and this as capital B and this as capital B, and join between A dash B1 dash with little bit thicker than the XY line, and join A to B2, A and B2 with a little bit thicker than the XY line. So then now we need to find the top view and front view and its inclinations. So consider A dash B1 dash. So this is capital A and capital B. That means it is in the true length. So since the front view line is true length, so correspondingly in the top view that line should be in parallel to XY line. So A is on XY line. Therefore B1 should also be on XY line. Then only the line will be parallel. So with B1 dash as center, so draw a vertical projector from B1 dash to the XY line, and you mark this point as B1, which is as shown. With A as center, taking the radius of AB1, you rotate it such that it will going to cut the locus of B in the top view. So you mark this point as B, then join A to B with a dark line. Similarly, you take the front view now. To find out the front view, take the top view true length. So the top view true length is A, B2. A dash is above HP by 20 mm, and then you have drawn this horizontal line. So since it is the true length in HP, obviously that line should be parallel to XY line in the front view. A dash is above HP by 20 mm, so B2 dash should also be above HP by 20 mm. Then only that A dash B2 dash is the line which is parallel to XY line in the front view. So you project from B2 till to the locus of A in the front view. So join A dash B2 dash with the join A dash B2 dash. So A dash B2 dash is the line which is the top front view for the top view true length. So with A dash at center, because due to the presence of the locus of B in the front view is above XY line by some distance, with A dash at center, taking the radius of A dash B2 dash, by using compass you draw an arc such that it will going to cut the locus of B in the front view. Then mark this point as B dash, then join A dash B dash with a dark line. Then when you join between B dash and B, both should lie on the same line. Now we need to write the apparent length and apparent inclination. So A dash, by using the scale, you measure the length of A dash B dash, which is 71 mm. When you are doing it in manual, when you are doing it in computer, it will be 70.71. And the inclination made by this with respect to HP, which is alpha, which will going to be by using the protractor with A dash as center, you measure that angle. Alpha will be equal to 45.00. Then by using the scale, you measure the length of AB, so which will be equal to 86.60 when you are doing it in computer. When you are doing it in manual, it will be 87. And then by using the protractor with reference to the XY line, you measure an angle and you measure that angle which will be equal to 55 degree when you are doing it in manual. When you are doing it in computer, 54.74 degrees. So this will going to be the final answer which you need to write. This is how you will be able to analyze this problem on projections of lines having given the true length and its true inclination with respect to both HP and VP. Thank you.